Hello everyone. So today we will be continuing on integration from where we left off. So in our last video, we basically went through the basics of integration. So if you had function f of x is equal to 2x squared, then the integral of f of x would then be, you do the opposite of differentiation, so you would have 2x. Sorry, I switched up the colors by accident, but let's just ignore that for now. But yeah, so first we added the power, and then we divided the thing with the new power, which was 3, so 2 plus 1 is 3. And we had the plus c, which is the constant of integration. And we would then get 2 over 3 x cubed plus c. So now, let me extend our definition of integration to functions such as g of x is equal to 2x plus 3 whole cubed, or h of x is equal to 4x plus 3 to the power 5. Okay, so usually when we differentiate g of x, let us differentiate g of x, right? We differentiate g of x, what we would do is the power would come down, so we'd see the power go down, so we'd have a 3 there. And then we differentiate what is between the brackets, and then the power here falls by 1, so we have 3 minus 1, so this becomes 3. So what if you differentiate what's between brackets, we get times 2 times 2x plus 3 to the power of 2, and then we get 6 2x plus 3 squared. So that's what we would get when we differentiate. So as we know, integration is the opposite of differentiation. So we basically do the steps of differentiation in reverse and the opposite. So the last step which we did in differentiation was to multiply by the derivative, right? So when we integrate, the first step which we would do is we would sorry, let me switch again. The first step which we would do is we would add 1 to the power. So here, if we are integrating this, we would add 1 to the power there, and then after that we would divide by the new power, which is 3. But then there's a difference when we integrate this. When we differentiated, we had to differentiate what was between the brackets, right? And then we multiply that to our new function. So here, instead of multiplying with the derivative of what's between the brackets, we divide by the derivative of what's between the brackets. So then we would have, 2x plus 3 differentiated. So then we will get 6 2x plus 3 cubed over 3 times 2, and then we go back to 2x plus 3 whole cubed. So now let us then use our understanding of how this works to do a question such as, so let f of x be 3x plus 5 to the power 5. So how would we integrate this? So let's go. So the first thing which we did was we added 1 to the power. So we added 1 to the power. So we would have here 3x plus 5 I'll just do it here. 5 plus 1 over, then we divide by the new power, which was the second step. So 5 plus 1 is 6. And then we have to divide by the derivative of what is between the brackets. So if we do that, we'll get 3x plus 5 to the power of 6 over 6 times, if we differentiate what's between the brackets, we will get 3. So 6 times 3, and the answer becomes 1 over 18, 3x plus 5 to the power of 6 plus c. Always remember to put the c. It's important. There's always a mark for this c. So now let's extend our differentiation, our principles of integration, and generalize. So if we have a function where f of x is equal to ax plus b to the power of n, if we integrate that, we would get ax plus b. We add 1 to the power, so we get n plus 1, divided by the new power, which is n plus 1, and the derivative of what's between the brackets. So that is ax plus b, and this will then become the formula. So ax plus b to the power of n plus 1 over a times n plus 1 plus c. So this would then be the general formula if we're going to integrate a function of this form. So now let us talk about functions of the form like, let's say, g of x is equal to 1 over x squared, h of x is equal to 3 over x to the power of 5. So how would we integrate these? So the first step you would do is, you would first express these in terms of powers of x. So 1 over x squared can be written as x to the power of negative 2. 3 over x to the power of 5 can be written as 3x to the power of negative 5. So we use the same principles of integration like 4. So the first thing we do, so if we integrate g of x, the first thing we do is we have our x to the power of negative 2. So we add 1 to the power, and then we divide by the new power, which is minus 1. So this becomes x minus x to the power of negative 1, which is 1 over x. So if we are going to integrate h of x now, we do the same thing. So we have 3x to the power of negative 5. So the first thing we do, add 1 to the power, followed by, then we divide this by the new power, which is minus 5 plus 1, which is minus 4. So therefore, our answer then becomes minus 3 over 4 x to the power of negative 4, and we can rewrite this as minus 3 over 4x to the power of 4. And the most important thing is to always put that c, the plus c. So essentially, you use the same principles of integration as you did before. So if it's the form like 1a over x, like where a is a constant, just ensure that you write your x in, like you convert your x to a negative power so that it becomes easier for you to integrate. So we can then use this and extend our definition to things like if we have, let's say, f of x is equal to 1 over 2x plus 3 whole squared. So the first thing which we would do is we convert this and write this in this form, 2x plus 3 to the power of negative 2. So as we did before, we use the same principles. So the first thing which we do is, so the integral of f of x becomes, so you have 2x plus 3 here. So you add 1 to the power, so you get minus 2 plus 1. Then you divide by the new power, which is minus 2 plus 1 is minus 1. So you have minus 1 here. And then since it's a function like this, you have to divide by the derivative. So you differentiate what is between the brackets. So then if we do this, we would get 2x plus 3 to the power of negative 1. Oh yeah, we have the minus here since we're dividing by minus 1 over, if we differentiate what's between the brackets, we get 2. And this can then be rewritten as minus 1 over 2 times 2x plus 3. And then you always have to put the plus c. So basically the same exact concept, is just the power is a negative. So you use the same thing, there's no change. Now let us try look at this function. So let me start to change the ink. So let's say we have f of x is equal to 1 over x. So how would we integrate this? So okay, let 1 over x be x to the power of negative 1. Yeah, so the first thing we would do is rewrite it, obviously. So let's try to integrate this. So integral of f of x dx, and we have x to the power of negative 1. So the first step, as we always know, is we add 1 to the power. Then the second step is we divide by the new power. So let's see, what's the new power? Minus 1 plus 1, which is 0. So we divide by 0. But then if we look at this, you can't divide something by 0, and that because anything divided by 0 is undefined. So if you remember from differentiating, let's look at this function. F of x is equal to ln of x. How would we differentiate this? So the first thing which we would do is, if we differentiated ln of x, we would get 1 over x. So therefore integration is basically the opposite of differentiation. So if we are going to integrate 1 over x, it will then become ln of x. So that's how you would differentiate. So now if you have something like f of x is equal to 1 over ax plus b, sorry, let me make 1 over 2x plus 3. So if we differentiate ln of x, right, ln of 2x plus 3, right, we would get, so we differentiate what's between the brackets, so we have 2x plus 3 bar, and then you get 1 over 2x plus 3. And then this should become, if you differentiate what's between the brackets, it's 2, so 2 over 2x plus 3. So integration, as we know, is the opposite of differentiation. So we basically go in reverse. So if we integrate that, we get, so we would have 2 over 2x plus 3 here. So the first thing which we do is we make it into 2 ln of 2x plus 3. That's the first thing which we would do. And then after that, since we multiplied by the derivative of what's between the brackets when we differentiated, now we basically divide by the derivative of what's between the brackets. So then if you do that, you will get 2 ln 2x plus 3 over 2, and that's ln 2x plus 3. So now let's try integrate this. So here, integral of f of x. So the first thing which we would do is we would make this into the form ln 2x plus 3. And then from the other side, what we then did was we divided by the derivative of what's in between. So we differentiate whatever is in between. And this gives us half ln 2x plus 3. And you have the plus c. So therefore, if you have any function in the form of f of let me just do this. Yeah, f of x is equal to 1 over ax plus b. If we integrate that, we would get, so the first thing which we did was we made it into ln ax plus b. And then the second step which we did was we divided by the derivative of whatever's in between. So there, this becomes the general formula. And you have the plus c. Okay guys, so this is the end of the video. In our next video, I will be talking about our extending the definition to powers like f of x is equal to e to the power of x, and we'll then talk about definite integrals. All right, thank you guys. You guys can look forward to the video like this weekend. I'll definitely make all the videos before Tuesday, so you don't have to worry about that.